G'day there, my name's Timbo Turtle. Now we watched a few videos lately and noticed people, both globers and flat earthers and the like, using AutoCAD to do their little experiments, etc. That's fine, and not everyone has the access to it, but for those who do, I thought I'd just do a little tutorial. Now I've been using AutoCAD since the early 80s. The first version I used was 1.0 for DOS. So I'm not quite familiar with it. It's something that I actually use on a daily basis for my work as a civil designer. So I thought I'd start and then trying to be impartial one way or the other, just give some advice no matter which side you fall on as to how to use AutoCAD. Now, when you get to start up AutoCAD, you'll get your drawing. You always start a new drawing by going over and going new, and that'll bring up a blank drawing or template, depending on how far you get into it. One of the other things, though, you should always be aware, AutoCAD is pretty much just a blank tool. For it, if you draw a line of 1 unit long, it has no idea whether that line is 1 mile, 110, or what, 1 parsec, 1 light year. It doesn't care. As far as it's concerned, it's just 1 unit. You're the one who determines what size that unit is. Now, for some people, it's best to work out what that should be to start with. So if you go into AutoCAD and type in units, you're able to say what units you're going to use. This is more for if you're saving it and then you're going to bring into another file where you've used a different set of units. AutoCAD then knows which way it is and is able to convert one file to the other. But within the same session, AutoCAD tends to use the same units. Now, usually I would use meters, but as one of the things I was going to test was this the 8 inches per mile squared I thought, okay, for this case, I might use miles, since that's what the 8 inches per mile will use. So I would go miles. To make it simple, and in this case, that's going to draw a circle. But there are some pretty basic lines. Now, you can learn the very basics of AutoCAD in, 20 minutes or so. You just think, if you want to draw a line, type in L for line. You'll see when you in AutoCAD in these more later versions, it'll give you all the commands that start with here. So you can go line, and you'll get a line. Obviously, easy enough. You'll see when you start to draw the line, and you click on any point, you'll see the length. If you want that to be a specific thing, just type in the length, and it will draw a line that long. Pretty straightforward, really. There are some other tricks and trade about getting to, but just getting you the general basics. If you can't remember a line command, you can always, if you go into your ribbon menu at the top, which I always recommend to people use, particularly if they're starting off, you can pick your lines, your circles, and other elements from there. And there's all sorts of stuff. I mean, there's literally over 500 or 600 commands in AutoCAD. And the more, as I've been using it over 30 years, there's heaps of little tricks and of the trade you learn, particularly in terms of editing. And what we're doing here is really, really basic in terms of what AutoCAD can handle. So let's just continue with the very simple stuff. As I said, AutoCAD is really, in this element, just a drafting program. It just draws whatever you tell it to. And it's pretty much garbage in, garbage out. But let's try not to put garbage, let's actually put something sensible in. So, as I said, first command, let's draw a circle. Now, as we're going to test the idea of the shape of the Earth, or the curve of the Earth, let's draw a circle that is actually the size of the Earth in miles. So what I've just done there is put in the circle. The first thing it asks for me down the bottom here was where the center of the circle. So for the start of it, I'm just going to assume the circle is 0, 0. Sorry, I'll just start that again. So we'll start the circle, draw it here, and then we're going to type in, now in miles. Now I'm not a person who uses miles, but like most of the world, I use metric. But for this case, let's go with miles, which is 3958.8 miles. Is the radius of the suggested radius of the Earth. Now I'm not trying to impose that that's the case, but we're testing the supposed curve of the Earth. So let's use that. Now of course it disappears. That's because it's too big. It's the circle I drew before. Let's get rid of that. Now what we can do, if you click on something, you can go over to your own properties window and see the information about it to check that you got the right one. In this case, I must have drawn a circle before. So let's try again, 3958.8 miles. So that's now the correct size. The diameter, of course, being the same, and we're going to draw it at 0, 0. So there we go. A circle, supposed shape of the Earth, in miles. Now, just to make life easier, I'm going to change the properties of that and change its colour. Let's go with green. Why not? If you wanted to change that without knowing where the properties are, if you double click, you'll get a little quick properties window where you can see the properties and make any changes you wanted to using that. It's quite a handy way of stuff, and also if you wanted to check what you've done, that's also a good way. So again, now we have the shape of the Earth. Now I'm going to go up to the very top of the Earth, and to make sure I'm at the top, there's several ways you could do it. You could go from the center and come up to the top. Now you might notice when I click on something, it gives me what are called snaps. So in this case, I have some snaps turned on by default. In the case of center, so when I'm on a curve, if I'm hover over the edge of a curve, it'll snap to the center of that. You have other snaps. In this case, that's the intersection, and you have a snap, which is the end point. Now, just in AutoCAD, for those that want to learn AutoCAD, you'll notice that the shape of the snap changes, so you know what it is. So the snap is a circle for the center, a cross for an intersection, a square for an end, and there's a few others, but I won't go into that now. I'm not doing a full lesson on AutoCAD, just enough to get you by. So that will make sure that's the top of the circle. Another way you could do that is use a snap called quad, which will pick up the quadrant, which is also the same point. So if I wanted to know where, for example, the edge of the circle was from a cardinal point of view, I could use quad to select the edge of the circle, and that will give you, for example, the outside edge. So we'll ignore that for the moment. Let's erase those. Okay, let's come back and we're going to draw the top. Now, one of the things I thought I would do, what's the height of Everest? I think it is 5.9 miles. Let me just do a quick Google search off the side here. Everest height in miles. I know what it is in. It is 5.498. I wasn't close, so 5.5 miles. Okay, so if I wanted to say, pretend I was drawing Everest, and we know that it's 5.498 miles. Only reason I'm doing this is just to give us something to worry about. That would be the size of Everest on the top. So I'm just going to do a quick little draw of a mountain. We'll mirror that. Be a little bit artistic. And say, hey, that's Everest. And if this was flat Earth, it would look something like that, relative. And if you follow the globe model, of course, you would find that it would disappear because, relatively speaking, even though it is the tallest mountain on the Earth, relative to the size of the Earth, it's not very big. But coming back to Everest for the time being, let's get rid of that little line, and there's our line and the other one. Now, so that's pretty much basics. AutoCAD is all that sort of stuff. If you want to draw a line, draw a line. There's a few commands in there. If you wanted to draw a tangential line, draw your line, type in tan for tangential, and you'll see that'll make a snap to the line. If you wanted to draw a line perpendicular, pick a point, type in P for perp, you'll get perpendicular. If you wanted to draw a line perpendicular to a center, draw your line, get your center snap, as I told you before, type in perp for your perpendicular snap, and you'll get the line perpendicular. Pretty straightforward. Regardless of what you believe the shape of the Earth, it's easy enough to use. The advanced techniques of AutoCAD is when you get to actually designing stuff and editing stuff, and the speed at which you do it, that's when you want to have some skills. But if you're playing around at home, you do have plenty of time. You can just muck around with it as you want to. Now, okay, we've done that. So what do we want to do? Oh, well, let's say we wanted to work out this 8 inches per mile squared, which is what I thought I'd use this for. Now, what I could do was, okay, I know that I could sit here and draw every 1 mile. Go like this, create an offset. Okay, that's 1 mile. And then I could say, okay, let's draw this over here. We know that's 1 mile. And what is the drop in that? If we wanted to sit there and work it out, I believe we would find it is something like minus point, what's it, minus 0.01. So you sit there and go, oh dear. Sorry, I'm just working this out in my head. Okay, if it is 8 miles per mile squared, you'd go, okay, that's going to be offset of 0.012, something like that. I could be wrong. A bit irrelevant, but I'm just giving you the point of view. You find it's really, really small, which is not what you'd expect after a mile. You come over here and you draw that in, and there's your first one. You get rid of the other ones so that you're just looking like, as you can see, that's going to be pretty tedious if we did that. We could speed it up and we could say, okay, well, let's do it over 10 miles at a time rather than 1 mile at a time. If we offset that relative, that's 10 miles. Again, we'd work out the distance and draw it. That's again, but if we wanted to draw this whole thing, that's going to take us forever. So I thought, bugger that. Now, one of the things, of course, in using AutoCAD over the years, I've learned quite a few little tricks and trade. If I'm doing some things like this particular one, and I'd say, oh, okay, I've got to plot this stuff up. One of the tricks would be to draw it, to do the calculation somewhere else, and then get AutoCAD just to paste it. Now, the biggest thing I've learned over the years is never type stuff in unless you can find another. If you can get the computer to do the work for you, get the computer to do the work for you. So I thought, okay, well, let's do this in Excel. Now, Excel's pretty straightforward too. It's just information of sheets. You put in cells and work out formulas. Straightforward. So in this case, I've written very, 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 very basic Excel format. So that if I put in the numbers here, which is the separation I want. So in this case, I want a separation of every 10 miles. And then I have here, drag that's the starting point, which is that cell. Then the next cell takes this cell and adds 10. Now I got a little bit of fanciness in there, which is just looking to see if I've run out of numbers based on this maximum number. But that's just so I don't make too many of them. But basically, we end up with the numbers going from 10, 20, 30, 40, so on and so forth, all the way down to 3,940, which is basically, if you are following the globe Earth, is the expected radius of the Earth, or the considered radius of the Earth, let's put it that way. So on that basis, we also then want to work out, well, if we're going to use this formula of 8 inches per mile squared, what I've done over here is, this is what 8 inches per mile is in miles, because obviously we're working in miles, so we need to use all our units in miles to get the right answer. So it's 8 times 1 over 63360. Now, Google tells me that's how many feet there are in a mile. I don't really know. As I said, I use metric. I trust Google on this. If I'm wrong, I'm sure someone will let me know. But anyway, let's assume that, and that'll give me a number. So that is, what, 8 inches per mile. So if we take our miles, times it by that number, we'll get the expected drop using that formula. So all I've done, taking that, we take that same formula, and as you can see, anyone who's used to Excel can see all the formula is doing is taking this number, times it by that number, see, puts it in a different color so you know which cell it's doing it. So that number times that number, or in this case this number times this number, and in this case I'm timing it by -1 because obviously the drop is going to go down, so because it's down it has to be a negative number. If I didn't put the down in, it would be a positive number and the curve would go up instead of down. Obviously we want the curve to go down because we're starting from this side. So then what I've done is drop that number down, and that gives me effectively, if I go 10 miles that's a drop, if I go 20 miles that's a drop, if I go 20 that's a... Now that's effectively also x and y coordinates. So if I made this 0, 0, let's pick up the whole object. As you can see, that selects everything. And I come down to here, go from there, and we can't. And I'd say, okay, let's make that at coordinate 0, 0. And zoom extents again. zoom back in, you'll see that that is now 0, 0. You can see the coordinate showing there. Now, on that basis, go back to my spreadsheet here, and we can see that would then be the coordinates. Now, I obviously could sit here and go, okay, let's draw a line, and then type in the coordinate 10, comma, and I don't know if this is exactly right. This is just a quick guess, and then so forth, so forth, so forth, so forth, so forth. That's going to take forever. I'm not going to do that. As I said, I hate typing in numbers. I'm not bad at it, but I hate typing numbers. So what I've done here is a little trick in AutoCAD. If you paste commands to the line, it'll accept them, no matter where they come from. Now, you can use a thing called a script file, which is basically a text file with the commands in it, and you can load the script file and then I've placed them in the road. I could have written a little program to do this, but in this case, all I want to do is, rather than me manually typing in, I'll type it from AutoCAD. So all this here is taking that line and that line and putting a comma in it so that it's the coordinate. Now the command I want to use is pline. Pline just stands for polyline. The difference between a polyline and a line, if I draw lines, each of these is separate. If I try to move one, then it moves just that one. I'd have to pick up the whole lot. That can be a real pain when you've got a whole lot of elements in that line. If you use pline or polyline, when you do the same thing, this is now one element. You can pick up and move things element. If you pick up and change the properties for it, you're changing the properties for the whole element. So we could do that. So we're going to use polyline instead. So coming back to here, we come down to here. So all I've done here, if you put in the commands in order in AutoCAD, in Excel, as long as it assumes that each new line is a command. So it would be the same as me typing in pline, enter, then it would ask for the coordinate, then ask for the next coordinate, then ask for the next coordinate, and so forth. So that's all it is. There's nothing overly fancy, but it just saves you a bit of work. So if I select all those as a whole range, we come all the way down to our 3,900. And we go copy. Now, I'm going to zoom back out so you can see what happens when we paste it in. Because it's a whole lot, it'll actually look like an animation, although it's not strictly one. So you're drawing a line. Oh, as you can see, that's a bit of a problem. Now, I'm sure all those who's looked at this would realise, anyone who'd done any math would realise that formula, 8 inches per mile squared, is actually a parabola. Now, I'm quite familiar with parabolas because as I said, I'm a civil designer. I design roads, and you may or may not know this, but actually vertical curves in roads, in other words, when the road goes up and down, is actually a parabola. That's how we design them. That way you get a nice smooth in and out of the curve and then back up again. So, yes, that looks like a parabola to me. So now we've drawn this in and we can see, okay, it doesn't match the shape of the Earth. Willing to go try it out and test it out, see if you think I'm wrong. But regardless, let's say we've done this. Can we use it at all? Is it useful? Now, well, let's have a look and see is it any use when we're closer to the Earth. Because obviously at full size it's not. So if I take my little thing, and rather than let's working from the top of Everest, which of course obviously not many of us are going to get to go from there, and we raise that Everest line, say, well, how far close to the edge of the Earth is it? If we use that supposed radius. Let's come out, say 80 miles, see what we've got. Coming out some distance, otherwise you don't get much of a change. Let me zoom in. Okay, you can see the distance there. So if we go from one to the other, green being the perfect, you can see that's 0.3 miles. Now, I'm not a miles person, so I need to convert that into something a little bit relevant. Let's convert that into feet. Okay, if we do that, that's 1.72 feet. Now, 1.72 feet over 80 miles. It's not a lot. So, if you're looking for some sort of variation of between 1 or 2, the error is not a lot in that sort of distances. So if you're going to talk about that, using that 8 inches per mile squared over small distances, say less than 80 miles, let's say 50 miles, then I think you're going to be fine. We'll do a little check. We'll do 50 miles, see what happens. Then we zoom in, see what distance it is. Come in again, do that little measurement, 0.001 feet. So as you see, it's getting smaller. If you're coming down to 1 or 2 miles, I think you're going to find it's going to be close enough for most drill calculations and comparisons. If you're comparing about an inch or two, then maybe that might be not the right thing to do. But if you're talking in the order of feet or tens of feet or miles, then yes, over those short distances, it's going to be close enough. Now that we've done that little thing, another little thing to look at. So effectively what I'm saying from there, if you're a flat earther, don't say the earth is 8.8 inches per mile squared. That's rubbish. It's not true. And that's why the globe is going to laugh at you if you continue to use that. But if you're going to say that 8 inches per mile is a good approximation for short distances, absolutely a fair statement. I think you could get away with that quite easily. Now, let's have a look. I'm not here to really go over the drop of the earth or that sort of stuff. But one thing else I did want to have a look at is, okay, well, let's have a look. What curve do you actually see? Now, we've come down here after my little thing. Let's draw 1 mile at world scale at that rate. Now, 1 mile, that looks flat. If I draw an actual flat line next to that, let's go here, we draw a perfectly flat line next to that. I can't see that difference between those two lines at a mile. So if you're going to say you should be able to see the curve of the mile, I think you're also a bit wrong. But it also goes to say for globers, you can understand why someone looking at that would think that the earth is flat. And it would be really hard to work out one or the other. So coming from that point of view, if someone says part of their visual proof is that they look out at the horizon and they see a flat line, I think that's probably fair enough to say that's proof, but it's quite clear to say that it doesn't matter whether you believe in a flat earth or a globe earth, it's the same. So again, both sides should not be pushing each other on that. Basically, you look out on the horizon, it looks flat. That's fair enough. Now we can start to get into other arguments about scale and distance, different matter. But let's just come to agreement that, okay, if you're on the beach, you look out at the sea, it's going to look flat. Now, if you want to measure that lately, yeah, there are other ways of measuring that, but it's definitely going to look flat. I think, now, I recommend, yes, you get into all sorts of stuff when you get into AutoCAD. I'm not going to take this any further at this point. I'll probably use it in another video another time. I hope that's been of some help to you guys. Okay, see you later. Have a good day, and hooroo.